Hello guys, here Gabby again. Today we are going to talk about solid principles in .NET microservices focusing in clear architecture style. So we know that a lot of teams claim that they follow solid principles, but then when we open the code and we see handlers doing everything, repositories full of random methods, integrations leaking vendor models everywhere, and clean architecture that's just folders and nothing more. The result is always the same. It's hard to change, it's hard to test, and it's fragile under growth. So, in this video, I will try to explain from my perspective what is solid in a production way, and I will try to connect each principle with some examples and how we do it in .NET microservices with clean architecture. Okay, so we have SRP, OCP, LSP, ISP, and DIP. Okay, SRP in handlers, gateways, middlewares, and repositories. OCP with multiple providers and strategies. LSP with dependency injection, contract integrity. ISP with small interfaces per use case, and DIP as the core principle behind application infrastructure boundaries. So, here is the simplest way to understand solid. Solid is not about writing perfect code. It's about writing code that survives change, okay? And microservices are changing machines, so we need our microservices that change all the time because they are small, reusable, unit deployable systems. We need that to implement solid in a correct way. Okay, so what is solid? Solid is a set of 5 principles to design software that is maintainable, extensible, and testable. So we have to remember that they are 5 principles that try to build our software as to be maintainable, extensible, and testable. Okay, we need to maintain the code, we need to extend the code, and it has to be tested. Okay, because we are focused around in microservices with changes. Okay, and microservices, as we said before, are changing machines. So in our stack we will see solid everywhere with clean architecture because the application depends on the infrastructure as in on abstractions. As I said in other videos, the applications know the what, knows what to do, but the technical details, the application layer must not know. Okay, the infrastructure is the one that implements them, and the domain layer is the one that stays protected. All right, so the structure is basically solid made practical. Clean architecture itself, we could call it, it's a solid, it applies solid principle. All right, so we are going to talk about all those principles. Okay, the first one from the S, single responsibility principle, SRP. SRP means that a class should have only one reason to change. Okay, only one reason to change. Give me a sec, please. So when a class mixes responsibilities, it becomes fragile to hard to test. Okay, for example, in microservices, when we are using the mediator pattern with mediator, handler had a clear responsibility that it is execute a use case. All right, so the handler did not do manual logging, do not build HTTP calls by hand and did not touch DB context directly. Okay, those concerns weren't separated. The logging, the correlation, the error handling, the middleware, or the pipeline. Okay, the HTTP integration, the Refit gateway in infrastructure, the persistent that is bounded to the repositories. If, for example, a concrete example that we could say is that if we have a handler of payment, if we want to process payment and we have a process payment handler that orchestrates the payment flow, the database access is handled by the repository. The external integration is handled by the gateway. Okay, we know the separation of concerns by itself from what is doing exactly there. A handler orchestrates the flow of the payment. The database access is handled by the repository. Okay, repository with the database access with the database, and the external integration by the gateway. So, summarizing the DS from Solid, single responsibility principle. A class should have only one reason to change. Okay, a class should only have one reason to change. Okay, we cannot mix responsibilities because a class then it's fragile and hard to test. Okay, because a class is an object that has a status and behavior, and we have to protect the internal status exposing certain behaviors. Okay, next, the O. The O stands for Open Closed Principle, OCP. We have SRP from S, and now the O, that the O is OCP, Open Closed Principle. Open for extension, we can extend, but is closed for modification. All right? Adding new behavior without breaking what already exists. We have a class that is an object that have a status and it has behavior. Okay? We can add behavior, but we must not break what is already working there. All right? So when we have more than one provider or strategy, we do not edit the handlers with an if else. Okay, we do not add if else for many implementations of the strategy that we are using. We extend the system with new implementations, and we have an abstraction, like for example a gateway, a contract, an interface, that then we use implementations. Okay, and through dependency injection we register this dependency and we abstract this. Okay, we add a new class and we register it with the dependency injection container. We do not touch the handler. So to add a new behavior, we prefer adding a new implementation, not editing the core. Okay, if we use, for example, a strategy pattern and we use abstraction, contract with an interface, and we have a gateway and so on, for example, instead of touching the core, we add a new implementation and we register this through the dependency injection. Okay, so summarizing, the O is open closed, open to extend, open to add, but it's closed to change the behavior. Okay, it's closed for modification, it's closed for the core. All right, you have to remember that we add behavior, we add things if you want, but we must not touch the core. Okay, So next one from the L, Liskov substitution principle, LSP. All right. If we have an abstraction could be a contract, an interface that, for example, resides in the application layer. Any implementation should be able to replace it without breaking the expected behavior. If I have a contract that clearly with clean code it says that it has a certain pattern of behavior, okay, with the Liskov substitution principle, we could change the implementation, but not change the expected behavior of the abstraction, of the interface, of the contract. Okay? For example, the implementations must respect the contract. If we have a gateway of loyalty, okay, and the loyalty defines give me all the points of that customer, any implementation that we add there should respect the behavior and the expected rule or naming convention that it have. Okay, it should return the same result type. It should handle errors consistently and respect the semantics that it have. Okay, so this matters a lot with dependency injection, because if one implementation breaks the contract, it blows at a runtime. Okay, so that's it. Let's remember, LSP is Liskov substitution principle. If what we change must not change the expected behavior. If we have a class, if we have an abstraction, any implementation of that abstraction should not change the expected behavior. I repeat, the Liskov substitution principle, it's a principle that says that if we have a contract, the contract says a behavior explicit, it tells an intention, all right? It tells us what it does. If we apply correctly Liskov, the implementation that currently is there, if we change that, we must not break or change the expected behavior. Okay, the return type should be the same from the result, the way it handled the errors, the semantics, and so on. Okay, so that's for the L. We need now the I and the D. Give me a sec, please. So the I, the interface segregation principle. We have another principle. Give me a second. So the ISP means that small and specific interfaces. Okay, interface segregation principle. Obviously, it talks about interfaces, and it says. Okay, give me a sec. It says it means small and specific interfaces. Nobody should depend on methods they do not use. Okay? Small and specific interfaces. Nobody should depend on methods they do not use. Example, we avoid giant interfaces like a generic iRepository of type T with 30 generic methods. Okay, because we can have a base repository, and an interface of iRepository could have a lot of hundreds of operations, and we would like to separate it in more customizable and small small pieces. All right. For example, customer read repository, customer write repository as interfaces, and so on. Or feature focused repositories with precise methods. If we have, for example, a vertical slice with Clean Architecture, DDD, and we implement CQRS with command and queries and so on, we could have repositories that implement through these abstractions and interfaces the behavior that is intended. For example, for customer, read customer, write customer, and so on. This reduces coupling and forces you to design around the use cases. Okay, so summarizing the interface segregation principle, interfaces should be small and specific. It should not be gigantic from, for example, a repository, a generic repository of a generic type D. Okay, we should prefer domain needed basis interfaces. All right, and last one, the D. We have the D. Okay, the D stands for dependency inversion principle. Okay, dependency inversion principle is something that we already talked about in other videos, but it says that with height and low, height level modules do not depend on low level modules. Both depend on abstractions. There is no dependency between modules, high level modules and low level modules. Okay, this is the heart of the clean architecture. The DIP, the dependency inversion principle, as an inversion because we have modules like layers, for example, application layer, API, domain, infrastructure, blah, blah, blah. For example, they could not depend on each other and is inverse. They depend on abstractions. Okay, so some concrete example. The application defines the interfaces. Okay, the application knows what to do and the application implements defines the contracts, defines the abstractions, defines the interfaces. The infrastructure knows how to do and how to implement those abstractions. Okay, and the API registers this relationship between dependency injection, okay, with the dependency injection container. As a result, the application does not know Entity Framework Core or Refit or the application only knows contracts. It knows what to do, okay? That means if tomorrow I change the external provider or change the database, I do not change the use case, okay? That's why dependency inversion principle is the core of clean architecture, because we can change things, but we do not change the model or the database. Okay, so in microservices, Solid looks like the first one: handlers, repositories, gateways, middlewares. Each one have a clear role. The SRP, the S, we remember it as single responsibility principle, that a class should have only one reason to change. Okay, a class should have only one reason to change. We do not mix responsibilities. And for example, a handler handles and executes things. The repository, it's in touch with the database. Then we have the gateways, we have the middlewares, and so on. Each one have a clear role. For OCP, open closed principle, when we add new implementations without modifying the core, okay, we have an implementation of an abstraction, okay, we add new behavior without touching the core. the Liskov substitution principle. Okay, if we have an abstraction, we change the implementation, the behavior must not be changed. Okay, the implementations must respect the contract, so they are replaceable. Okay, because the contract tells you what it wants. Okay, ISP, that interface segregation principle. That's it. That were small interfaces to avoid coupling. And finally, the DIP, dependency inversion principle, that is the core of the clean architecture. It is registered via, for example, via API, and we could have the application with abstractions and the implementation, the how, through the infrastructure layer. Okay, the application depends on abstraction and stays clean. The most important, to me, the most important principle from clean architecture is DIP, because it enforces the decoupling between application and infrastructure, and it is registered via the other layer that it is the API. How do we detect violations here? For classes that do everything, huge methods, many reasons to change, a lot of if-else branching, okay? And mixed dependencies everywhere, okay? So we know we are applying a good solid principles in the microservices if we can change it, we can maintain, and we can test it, okay? The foundation is the dependency inversion principle. The application depends on abstractions. The infrastructure is replaceable and the domain stays protected. I hope this helps you to understand better the solid principles. If you like and you get here to this time, hope you subscribe, like. See you next time. Bye bye.